to the third part, generating the random numbers. So within this probability. So sorry, the sunshine behind me is quite shiny. So my face is getting the dark now. But let's focus on the contents. So let me make myself smaller. And last video we practiced what's the possibility, means, and key concepts, probability, and also we practice the prime number count in count the probability inside our n numbers of sided dice. So I gave you the two these samples, and the second sample is the additional the one which extended the ones in the book. So if you like those discussions in my video, is welcome to follow my channel and give me your comments, and also you can get auto notification for the new videos I upload. And for this video is we talk about how to generate a random number. So it's we already tried that before. So random number is quite simple. So it's just if we use Python, you need to import this random the library, and we start is you just use random with random the method. If you don't give any inputs, they will generate one random number between 0 and 1. And if you use some other language like C, so you need to times. Maybe if you want to generate a number between 0 to 10, then you need to times this 10. So that is similar. Is if I do this, I can get our random number between the 0 to 10. So, but that's still our the decimal number. If I want to get our the integer number, then you need to give our range. So if I give our the range is a random the number, then with the ranges you can see here that is not by default is the random, is the run integer. Then you get this integer result. So you can see here. So that is actually the random. If you make it for I in range, maybe it's 1 to 11, then that's in range. Oh yeah, I should not have the space. Then so 4. Oh, sorry. So 4. Then print, just print I. So you get this is just 1 to I. But if I put is print the random dot rand int 1 6, then it's a simulate. You play the rolling the dice for 10 times. Then let's see. So you get this 1 to 2 3 3 1 to 2. So that is the so-called is a random number. But remember, is in language in C language that is not our real the language the random number. So possible in Python is not have that mechanism, because if you want to make a random number in C, you need to first define the seed. But looks like it's a Python is we don't have that the constraints. So, but anyway, it's just remember is you can have a random method that is our decimal number. You can have the rand int that is our the integer number. So we can, but integer number, let's just have our the. So let's see. So whether you can put the empty for the integer number. So you will get error. So it's a missing two required positional argument. So which means if you need the random integer, you need to give the range. the lower the integer, higher integer, then they will generate the integer between them with the this supplied range. And then let's do our the practice. Can you roll that score? So what's the practice means is simulate a simple die rolling game where we keep rolling the 6-side dice until we roll a total of 20. If you over 20, the game is also the stopped. So let's go to here is the, let's make it 0502. Now is, I think it's we are already in 5. So roll die till our score.py. So let me rename this. So this is the number 3. Oh, this is number 2. So so this is the second chapter. So the probability. So let's make that 3. And make this the purpose. Roll die until total score is X. So maybe we put this just extended is N. So then we ask user to input this N. So whenever you see is trying, you can have a possibility to prevent the hard code try to give a variable. So let's examine is what we need to do. Is what we will do is we will roll the dice. So this die have a range from 1 to 6. So first is we should have our random. So and whenever we do this function, so we call this a roll. So we don't need any the arguments, just return our random rand int, so 1 to 6. So since this only are one line, so you may think is we can make that quite simpler. So we just code this line directly in our main code. So that's true. So but what we are try to play in here, like the book is also is trying to demonstrate is how you can structure your code in more this clear way. So if you have some function that will be called repeatedly, try to separate that into our function. So that will later on is help you to expand your program larger and larger. So if I make our primary, so first let's implement ensure so we have our die rolling function correctly. So let's ignore those score. Then this just the roll the dice is let's see. So print roll. So that is a very simple way. So let me quit from Python and let me run. So if I got a number, then run again the random number. So that is simple. We got that. Then is our achievement need is we need to record every this random number and try to make the summary and compare is when it will achieve or over exceed this n. So first is let's have our n is equal to int input tell me the target score. Yeah, we will test using 20. So this one is we don't need anymore. So then we have this n and target score is n. So we can put this just target score to match the sample. Then what we will do is this target score should be inside this. I think it's here. The author make this as a constant. So they always call this a target score, but we create that as a variable, so we put that inside of primary this code. So we have our initial code as the 0, and then we see the while score. We use this while loop because we don't know how many times you will reach the target score. So that's not suitable for a for loop. So whenever score is less than target score, we will do something. So what we will do? So we will get the die row result. So just call this row, and then we count his number rows is equal to number rows as +1. So we need to have initial number rows is 1, and then plus equal row 1. That means it's number rows equal to number rows +1. So we will give our increment, and then print. We make this every row is we print this row the result. So row in number days is 0 and is 1. So we will put this as first is number row, and then second is die. So then we know is which time we go to which number. Then we put is the score plus equal to die row. That is equally like a score equal to score plus die row. That is then we get this summary. So that is fine, I think. So finally, we just print is while is over or equal to target score. We just print is first is final result. Then we print our score of 0 reached in 1 rows. So actually this information is already coming in the last the lines of this one. So then let's see run. So we use the 20. So you can see. So first is C row in number 1 is they keep counting, and finally is score is 20. So this is 5, 9, 17. Oh, it's directly the score of 20. So let's run this another. It may not be always exactly get 20. So it's more than 20. It's also finish this such kind of the this looping. The author also make this import. So I suppose is the author want to do some plotting. So let's make this. Let's see, we have two. Actually, within our code is we got two lists. One list is the number of row, another list is the score. So that is enough. Is we can make the score number, and they are having the same the element. So, but this score is should every score. So we should have our another thing. So number row. So every score is equal to our empty one. So here, so every score dot append the score and the number row. So let's run this to see. I think it's a number row is not may have the problem. So let's see 20. So that is I cannot make that. I also need to make this as a list. So O is if I don't make that, and I just make it as a one variable. Yeah, that's good. So let's say ignore these numbers. So it's just 20 times. I think it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, so it's, let's put let this plotting to automatically give the this the x. So this half is no matter because we don't need that. But here is the score. But actually, is we should have our average score. So average score is that is not this one. So I need to do this die row. Then let me run this. Let's see here. Then I know it's every time so what my dice looks like. So that is the this way. So we have our plotting. So, but I'm not sure is the author is want to plot for which way. So anyway, I show you is you can still use what we learned on the plotting to do the things. So let's continue. Is the target score possible? So now is we have our give our boundary score and we see is whether it's coming to that or over that. But is this if we set our target score, can this score being achieved? Like is can I get exact 20? Because here you see here sometimes I got 21, sometimes I got 22. Looks like it's not exactly is easier for us to get our target the number. So what this program want to see is whether a certain target score is reachable within a maximum number of rows. So we set is, oh, I want to dice 6 times. What's the possibility I can get 20? So that is the this second program doing. So let's do this again from the scratch. So I definitely you can copy from this number 3, but from scratch is can give us more practice. So row kill target score .py. So let's make our header. So the purpose. So now that you can see here, we need the set. So row die to the target score within maximum numbers of rows. So that's the constraint. So if you keep rolling, I think sometimes you must get those results. But possible is it will be beyond. So I see the logic for this program. Okay, so let's import needed things. Is we need our finite set, and also we need random. So we can directly import random. And let's see. So what is our random to be used is inside here. So I think it's the random is where the random to be used. Target, find, possibility. I don't see the random. Or am I wrong? So find the possibility. So it's a target score and the maximum rows we will put. But where is we make these dice? The row, die side maximum, target, find the probability with this one. Then die side. Oh, so we don't have this random. Actually, so we use this finish side. Then actually this is not used. So we're just trying to see the. So let's delete that. So using the set, I think is enough to make that. So let's make our primary code first. So for our primary code, we will do something and we will define the find. The probability is we give this target score and the max rows. So these are two things. Yeah, let's give a none so that is not generate the arrows. Then is we should accept the input for these two arguments. So target score, ensure is integer. Then we have the input is the enter the target score. And same is we have the maxi rows is equal to input. Input integer is the maximum number of rows allowed. Then we will call this possibility. The possibility will return our the P is we will find the possibility, transfer target, score, and maxi rows. And we will print the probability is 0. We give 5 digits. Simply P. For 0 within 1. So that here is 2. So let's have all of them. So target, score, max rows, and P. Print. So I might have here. So let me see. So I have a 25. So code is unsupported format string passing to none. So I have this none. So return true. So let's just return something to check is our primary folder. The program is okay. So probability for 20 within 6 is this one because I return P is true, so that is 1.0. So now its logic is good. Let's starting to put this. What we will have is we should define the die size. So not using the random. So it's just our finite set from 1, 2, 3, 4, 5, 6. So that is our size. So we then this random is not here. So S is we use this Cartesian this product. So it's the die size times max rows. I'm not sure it's why here is using the square. So times the squares. So that is the string. So let's put in here is if max rows maximum 1, then this success rows is we will give the empty here we use the target score, then we have the successful rows adding new the dice results. That is we are creating this the successful rows, this element list. Then if I back to if, so else if that is not be more than 1, then target score is more than 6. Success is this, just keep empty, and inside else we will have make that initial as empty for row in die size. If row more than target score is same, so S. Now we have our enough sets. Put is we will just do this new finish test. Set is using this list. The list is successful rows. Then we calculate just directly is the length. This E is our events, and length S is our the total. So max rows. So here is rows. Total is our the Cartesian this product. Let's try to do our testing. So I use 25. The authors mentioned, and 4. So what this means is finite test and support often. So I got both are the finite. So it that means here is the power. So that is the string. So let me see. So 25 and 4. Okay. So now I got is 0. Now let me put is 25 and 5 is 3, 2, 4, 1. So that is the good thing. So here is they use the power. So let's come to here. So large number. Back to possibility. When we're talking this the Cartesian, let's see here. The Cartesian product we are doing here. So if we apply the exponential operator to a set, we get the Cartesian product of that set times itself. So that means is if I put this max row, so max row is I put 5 times 5 maximum. So I will repeat this set with the Cartesian product 5 times. So so that is they should not be the Cartesian product only. So this is the count for the Cartesian product, and the actual Cartesian product is this die size times itself. So here is the reason is we use this exponential operator. So Now we can now make it if I have a target 100 and I give it 20 times. I got is let's see, so it will make some calculation. Then it's what we are putting here. Looks like it's quite long. That means I need 100 times Cartesian product this calculation. So or maybe it's quite large. So let me click that. Let me just see is 30, and I gave 5 times. 5 times means every time I need to have 6. Let's see what's the this possibility is very low. So the 13 is with 3 zeros. But if I put this 30, I allow is double times, 10 times, then the possibility is will be slower calculate, but it will have the higher possibility, I believe. Even this target 30 is not running quickly. So let's make that smaller. So 30, just 6 times. Yeah, you can see it's increased from this 00013 come to the more than 100 times bigger. So those are the possibility calculation we use this second sample. I hope you also generate the correct result. Actually, within this second sample is you don't need to import random since we don't use that inside the program. And pay attention to here is not the Cartesian product, it's the component show this ratios to the maximum rows, so that you do the Cartesian product of dice size itself for max rows times. So that is the thing is I want to highlight here. So see you in the next video. Then we will move to this non-uniform random number generation. Hope you like the video and try to practice yourself offline, or give me your comments if you meet any problems. See you then.